Hello everyone. Can you see me? Am I live? Write in the chat box so that I know that yes. Okay guys, so you can see me. Am I live? Okay. So you can see me, right? Okay, so let me now start. Hello everyone. I can see viewers Spurs, Ayon, Chiranjit, Manav, Aditya Raz, and all people. So tell all the people to join. Spread in all your group. So let them join. Before that, let me go over some information, some announcements. You know, UCL for JEE is back, right? Unacademy Champions League, and you see our mascot, our icon, Sachin Tendulkar. Aptitude test on 26 December, 1 p.m. onwards. Use this code. Do appear for the exam. Unacademy Champions League is back, and once again for you, participate and win. Lot of attractive prizes to be won, like you can see Apple MacBook Air, Apple Watch, AirPod, and whatnot. And best of all is that winners will decide on lucky draw. So there is lucky draw also. So who knows, you get lucky. Then iconic subscription offered is like mouth-watering offers. 6 months iconic subscription plus 1 month extension, or you buy 18 months subscription plus 2 months extension. Things cannot be much better. And then you have these batches, the Edge batch and the Striker batch and Excellence 2.0. You can study from your educator. And then Olympiad mock test series for JEE 2022 is starting December 25, 2 to 5 p.m. So that also you can check. This is boot camp going on day 3. This is going on some kind of camp. Let me tell you this also. For those who don't know, this is Alok here, and you can you can follow me on Unacademy. You can just check my profile and use my code AlokSirLife to avail discount on Unacademy subscription. Come to live classes. Come to my AHA lectures. Lot of them are there, and my classes also are running special classes and plus courses. You can join them. You can tell your friends about it. Others you can just read. And please follow the link. Please follow the link, because if you are following the Math Matters, like subscribe to the Math Matters channel. Many of you might not have done, because once you do, you will get notification on time. You will get what people are teaching, and if something interests you, you will not miss that. So please do subscribe. Okay, Yadnes, Clara, Bernie, and Unique, and other people. Okay, so let me start. See, this here, these problems are really tough. The problems of today's, because one, of course, in IMO problem, by definition, it has to be tough, right? I'm using the term by definition, okay, as if you don't know. Okay, then other things are like complex numbers, number theory problems, and how these all are woven around cyclic identities. So let me go and then ask you this thing. First only is the number theory problem. So they are saying that let P be a prime and K be a non-negative integer. So your job is to find all possible solution to the equation. This means P and K will get fixed, right? Because you can't have other than this. So how will you get to know it? So it is like this. See, if you take K equal to 0 or K equal to 1, we already know something that we discussed last time, that sigma y minus g, or you can reference it also, is 0, right? Sigma x times y minus g is also 0 because they all cancel. The real fun begins from x square y minus g when power is 2. Then you get negative of, when you multiply, you get negative of x minus y, y minus g, g minus x. Is that all right? Okay, so this you will get. So you are getting this kind of thing, negative of x minus y, y minus g, g minus x. Now, you want all positive integer solutions, right? X, y to the equation. Now, if I write this one, x cube, let me tell you this also, sigma x cube y minus g. Now, this is negative of x minus y, y minus g, g minus x. And if you do it carefully, you will get x plus y plus g. Similarly, sigma x to the power 4 y minus g, you will get negative of x minus y, y minus g, z minus x, and times x square plus y square plus g square plus xy plus yg plus gx. Means it is degree 2, it is degree 1, and all those things are coming up, right? So this is just this all you have proved already. So I'm just going through it to give you an idea, and also so that you can follow me more closely. Now, so this all comes from recurrence. Now, if you have got sigma x to the power k, and this is k greater than or equal to 3, because till 2 you know it is 0, then sigma xk y minus g, that is xk, if I spread out, xk y minus g, xk y minus g plus y to the power k g minus x plus g to the power k x minus y, that will be negative of x minus y, y minus g, g minus x, and times, see, here you have got degree 1, here degree 2, homogeneous polynomial of degree 2, multivariable like x, y, and g, 3 variables. Here also you will get some sigma. So I'll write, you will get sigma x to the L, I can use that, y to the power m, z to the n, means this L, m, and n, and it will be such that L plus m plus n is k minus 2, of degree k minus 2, right? Check it out here. See, k minus 2, 1, k is 3, so it is 1, k is 4, so it is 2. Next, when you get 3 degree 3 of x5, you will get everything of homogeneous degree 3, means you will have term like x cubed, y cubed, g cubed term, or x square y type of term, and then xyg term finally, right? So these kind of things are there. It's quite interesting. So you will get like that. I hope that is clear. Any doubt till here? Now so this factorization is done. Let's focus here. Of course, xyg is not 0 because p is prime. So of course xyg has to be distinct. Otherwise, if x equals y, then you understand that things will become 0 and p cannot be 0. P is a prime. P is a prime. Okay. Now out of x, y, and g, out of x, y, and g, out of x, y, and g by pigeonhole principle, some 2 of them must be the same parity. Either both are true or even, or 2 are odd. Means I will say some 2 of them are the same parity, because you have just 1. Okay. Now, if this is there, ph, then some 2 of them will be same parity. It means that x minus y is even. I mean, then this sigma is even. This is even. So if this is even, then that means that now p has to be, p cannot be anything else, right? P has to be then 2 only, right? Because p is supposed to be prime. So if it is even, if p is even, then I mean that p can be only 2. So p can be only 2. And if that is 2, then that is fixed, because if p is 2, then you know these things cannot exceed other thing, right? You need 2 only, right? And this is greater than or equal to 1, right? So what will happen here? Then it will force that this k becomes 2 only, because if k becomes 2, then you have got. So in conclusion, this is a tricky part. In conclusion, let me add something because I have run off the page. So the conclusion part is that here you are getting here you are getting now x square y minus g y plus x square y minus g. You have proved that p equal to 2. You have proved that p must be 2. You have proved that p must be 2. P must be 2 and k is 2. We have proved, and so you are getting x square y minus g plus y square g minus x plus g square x minus y is 2, and there are many x, y and g that will satisfy this. I can take this x, y and g as, say, suppose one example. Hello everyone, let me check if you can see me. There was some technical glitch, so let me check if I am live still. Can you see me? All of you, can you see me? Please tell if you can see me, because I was off there for quite some time. Yes, Anirvan is saying yes, so I can go ahead, right? I hope it stays this way now. I had enough of it. Okay, Chiranjit, you can see me, right? Okay, good. So I was here. I was saying that x square y minus g plus y square g minus x plus g square x minus y, that happens to be negative of x minus y, y minus g, g minus x, and then I can take x, y, g. I need that both of them must be 2. I can take x, y, g is n plus 2, n plus 1, or I can take n plus 2, n plus 1, n, and I can take n plus 1, n plus 2. You can just check one of the cases. For example, for this case, you will get x minus y negative, and x minus y you'll get negative 1, y minus g will get 1, or if not, you can change, and g minus x you will get 1. So this is 1, right? So this is y minus x will get 2, in fact 2. X minus y is negative 2. This is 1. This is 1 still. This is 1 still. But this is negative 2, and so you will get 2 as the answer. And so of course it is correct. So the final answer is that p equal to 2, p equal to 2, and k equal to 2, and then you can have many x, y satisfying this. So the question was this. It's an Olympiad problem. So let p be a prime and let k be non-negative integers. Find all positive integer solutions x, y to the equation x to the k times y minus g plus y to the power k times g minus x plus g to the power k times x minus y equal to p. So we figured out that p equal to 2 is the answer, and for that to happen k must be 2, and there are many x, y and g positive integers which can satisfy, so infinitely many. So we got the solution. Okay, let me go to this one. We have to prove this identity bc a minus alpha and all those numbers. This is a tough one. See, the form is bc a minus alpha, a minus beta, and a minus gamma, and all those numbers. But there is some hope. What I can do is that I can take care of these variables in this kind of thing. You know, one expression, I'll write one expression sk. This sk equals, sk I will define as a to the power k on 4 variables, a minus b. Please make a note of it. A minus c, a minus d, plus b to the k over b minus a. So there are 4 symbols a, b, c, d. I am working on the symbols b minus a, b minus c, b minus d, plus c to the power k over c minus a, c minus b, c minus d, n plus d to the power k over d minus a, d minus b, and d minus c. So these are the things a, b, c, d. Now, based on this, I can calculate S0, S1, S2 that we did in one of the previous lectures. You can check those videos. So S1 is 0, S1 is S0 0, S1 0, S sub 2 also is 0. The real fun begins from S3, and S3 equals 1. For two variables it was S2, for two variables, right? If you remember two variable like a minus b, I'll just write here to give you an idea that if it were two variable, you understand that there was one famous identity, a square over a minus b, a minus c, plus b square over b minus a, b minus c, and c square over c minus a. Subtract all from c equals 1, and then later on also. Okay, Chiranjit. Okay, so this is this. So you will get this kind of AK, BK, CK, DK. That is S0 is 0, 0, 0, and S3 is 1. Here A, B, C are there, but D is missing, right? So what do you think? What D could be? What can work as D? The form is looking something A minus B minus C is there, B minus C minus C is there, other things are there, but BC is there. So can you suggest, some of you, some of the viewers, that what D I have in mind so that I can apply this result? That may be obvious if you consider this one. So let me write this again a bit. So this is BC A minus alpha and like that. So let me add a page and write. So if you have got BC B minus alpha, look at BC A minus alpha. So if you have BC A minus alpha, so BC times, so I'll just write BC here. So you have got BC times A minus alpha, A minus beta, A minus gamma, upon A minus B, A minus C, upon A minus B, A minus C, plus CA times B minus alpha, B minus beta, B minus gamma, upon B minus A, B minus C, plus AB times C minus alpha, C minus beta, C minus gamma, upon C minus A, C minus B. Just check all these. This is what we are writing. And then you have to find this value only, So let me write the first term. So first term is this first term I'll write as ABC times A minus B, A minus C. This is A minus alpha, A minus beta, A minus gamma. This sigma you want. So I'll write ABC is out and sigma. And this is your A cubed minus alpha plus beta plus gamma A squared plus sigma alpha beta A minus alpha beta gamma over A times A minus B, A minus C. This one. Now think of this in four variables. So what you do, you bring in something D, you bring a D equal to 0. So write this as A minus 0. That's the catch, A minus 0. And similarly B minus 0, C minus 0, D minus 0. So this is A minus 0. If we write here B, it will be minus 0. Again C minus 0. So all things fall in place, A minus 0. So I can write this. So A minus, let me write D and I will put D equal to 0 later. So A minus D. So I can write here on the next page sigma this one. So sigma AQ minus alpha plus beta plus gamma A square minus plus sigma alpha beta rather A minus alpha beta gamma upon A minus 0, A minus B upon A minus 0, A minus B a minus c. This we can write, this one. Okay, this we are writing like this. Okay, if I'm writing like this, then what you can do, we know that that is 0. So from here I'll write that if it is a square something, then of course this all will become 0. So the only thing surviving is that I can write aq upon a minus 0, a minus b, a minus c, plus bq upon b minus 0, b minus a, b minus c, cq upon c minus 0, c minus a, c minus b, c minus 0, plus 0, dq means 0, plus 0, that's all. Okay, and that number, so I will write this as this plus dq. So aq, bq, cq, and if it was dq, I will write d minus a, d minus b, d minus c, that equals that equals 1, right? So we'll make use of this identity, and see other things are okay, because other things we can take care. So what will happen, that if this you take care, abc already is there. See, you check, abc already is there. This is alpha, beta, gamma, alpha, beta. So this all will not come. Alpha, beta, gamma is there, and upon this thing is there, alpha, beta, gamma. So you will find that our final answer will be, you have to do a lot of work, but because but we already covered that. So this will be abc. It will be abc is common already. See, abc was common already. abc was common, right? abc is common here. So you'll find abc and 1 minus alpha, beta, gamma upon this one, right? Because you want to prove, see, you want to prove this one. You want to prove c minus alpha, beta, gamma, this one. So abc 1 minus alpha, beta, gamma. So you will get abc minus alpha, beta, gamma upon abc, thanks to these terms. And so you will get here abc minus alpha, beta, gamma, and that is what is to be required. So it's a good problem. Many things, many identities can be set on this, and this identities is really important. So that is what we do. Okay, let me go to the next one. Okay, so this is a simple one, not very difficult, but then of course it has got its own charm. So such questions keep coming in American Maths Contest, AMC, or other university exams, all contest. Here this is one thing which is based on complex number, and so this really I would like you to pay attention to, that this is called generalized Tollmage inequality. So they are saying that if ABC, I also have given some questions for practice, so you can practice later. So you have got ABC and A prime, B prime, C are similar triangles with same orientation. So if they are similar, the one thing is this: if they are similar, this is the thing that is to be kept in mind, that if they are similar, if triangle ABC is similar to triangle A prime, B prime, C prime, and same orientation, I mean same orientation. Okay, so this A is A, this is B, this is C, this is A prime, this is B prime, this is C prime. So if they are similar triangle, so there is one relation that tells that you have got, then if ABC if these triangles are similar, then A times B prime minus C prime plus, or first I write A prime. So if this is similar to this one, A prime, B prime, C prime, so I write A prime times B minus C plus B primes times C minus A plus C primes times A minus B equal to 0. We can change the role of ABC and A prime, B prime, C prime. So I can write this as A times B prime minus C prime plus B times C prime minus A prime plus C times A prime minus B prime equal to 0. Right, so these things we can check. This is just applying this result only, result 1 only applied second time. This time just swap A with A prime, B with B prime, and C with C prime. So that should work. So that should work. So that is this. Now if this is the case, then you can we see it is A prime BC. So what we can do is that we can subtract. So you can subtract 1 from 2 or 2 from C, does not matter. So if you subtract that, what you get, in fact, when you subtract what we get, it will be quite messy. So let's drop this 2 and let's write one other thing which might be useful here. So this is a, anyway you know this is true. This is true because of cyclicity. AB minus C, BC minus A plus CA minus B is 0. This is cyclicity. So these two are same. So I approach with 1 and 3. 1 and 3 approach. So B minus C is common. I can subtract now. I'll get A prime minus A, B minus C plus B prime minus B, C minus A plus C prime minus C, A minus B equal to 0. Right? So let me go next page and write. So I'm getting A prime minus A, B minus C plus B prime minus B, C minus A plus C prime minus C, A minus B equals 0. This is 0. Now is the time to write all those things. So if you have got AB is here, ABC, and you've got A prime, B prime, C prime, anything, the vector alpha minus beta complex number, this one, this mod, is distinguished into points alpha and beta, right? So I can take mod of both, mod on all sides, mod. So I can write here A prime minus A, B minus C, and I can make it to this side negative of B prime minus B, C minus A, and minus C prime minus C, A minus B, and I can take a mod of both sides. So mod is mod of this plus this, mod this plus this. Now you know that by mod property this is less than equal to, this is less than equal to, this is less than equal to mod of B prime minus B, C minus C prime plus mod of C prime minus C, mod of C prime minus C, and times mod of A minus B, this one. And this was anyway mod of A prime minus A and times B minus C. So I will get here A prime BC, A prime BC passing to modly less than equal to, this is BB prime CC prime and plus CC prime AB, right? So just check that we are getting this kind of thing, that we are getting BB prime CA and CC prime, BB prime CA we should get. This is C, B minus B prime, this is C minus A. So we should get BB prime CA. So we are getting this less than equal to BB prime CA plus CC prime, then AB. So this is what we get, and it is called sometime generalized Ptolemy's inequality. Generalized Ptolemy's inequality. Generalized Ptolemy's inequality, much powerful. Ptolemy's inequality. So we get this Ptolemy's inequality. You can check that we got this result. Is that clear? This result is clear to you, all of you? Okay. Okay. This is another of that same flavor, but little difficult and understandable. That how you reduce to this form. So P be arbitrary point in the plane of triangle, and ABC and different from its vertices. So P is different from vertices. So if there is a triangle ABC, all it says is this, that if you have triangle ABC and P in the plane of triangle, so P can be outside, inside. I am showing just one possible position, outside, right? Okay, so I hope everything is clear. So Priyanshu, it is clear? Okay, good. Okay, now Mr. Nobody, you can check my other videos in which I have told in detail about what kind of books you should read for Olympiad. So you can go through them. I think available on this Math Matters channel. You can check it. Okay. Okay. So ABC is here. ABC. And P is a point outside or inside, does not matter, but P is different from A and B and C. So P is not ABC. P is not ABC. Now, first question is how to write it as cyclic identity or something following. That is the question. If I multiply P, A, B, C throughout, if I multiply, I get PA times PB times AB plus I get PB times PC times CA, PA PB, PA, no, P, AB BC, PA PB AB, then I get PB PC BC, I get PC PA CA. This is greater than or equal to AB BC CA I want. Means I just wrote in this form. It might be easier to check if I put in this form. So let us check that whether it is easier to do or not. That way we'll do like this. That if P point I will take as origin. P take as origin of complex numbers system, argand plane. A as usual I will call A only. This is B and this is C. Although sometimes this may be unfortunate because A, B, C are only by sides of triangle, and so you can take alpha, beta, gamma, or you can take P, Q, R for better clarity. So that thing must not be lost on you. A, B, C is just natural. It saves you a lot of trouble. But I would hope that someone will take P, Q, R or alpha, beta, gamma. Now PA minus PB. So if I can, so PA. So this is mod A. This is mod B. And mod of A minus B and something similar. These numbers. This only want greater than or equal to this one. AB BC CA. That is modulus of A minus B. Modulus of C minus A. Like that. So how do you do that? Like what is the tool to do it? So can you just say that how we can do it? Is there some kind of thing that tells you that how we can do it? Some identity which involve exactly these numbers AB minus BC. So if you look closely, you will find that the identity for case equal to 2 S2 will work. AB minus B reminds me of that. So let me write on the next page that already we know that A square B minus C, it may be complex or real, plus B square C minus A plus C square A minus B. This number we know is negative of A minus B, B minus C, C minus A. Now this number is this, A minus B. Also I can write this as same thing as this is A square B minus B square A. So I can write AB common and A minus B. So this thing also equals sigma AB A minus B, right? Because again you can take sigma BC minus C and sigma CAC minus B, correct? So this is there. This is okay. Now see. So it means that we got this one AB minus B. So this I need to draw. So I'll write here that AB A minus B. Just a restatement. So you will get AB A minus B, BC B minus C plus CS C minus B. That equals negative of A minus B, B minus C, C minus A. Right. This will appear so many places. This factorization. So please make a point of it, so that you don't have to derive there. If you derive, your time is lost, and then I think that's not good in any contest. You must know them by heart. Now this is the like this. Okay, now what will happen? Now I can write modulus on both sides. So modulus of AB A minus B plus modulus of BC B minus C plus modulus of CA, rather all of modulus, sum of all, and equal to modulus of A minus B. This is separate, B minus C, C minus A. It all turns out that if you do this one AB minus B, if you pass to modly, this number modly, this is greater than equal to, this is less than equal to, this is less than equal to, this is less than equal to, you have write AB minus B. So I can write here less than equal to modulus AB modulus A modulus B modulus A minus B plus modulus B modulus C modulus B modulus C modulus A minus C and other term, more term. So let me write only modulus C modulus A modulus C minus A. So this is less than equal to this, and this is this. So I mean I will get that modulus of comparing this 1 and 2. I will get that modulus of a minus b, b minus c, c minus a is greater than or equal to modulus of a, c minus b, and modulus of ab, modulus of a, modulus of b, modulus of a minus b. Lot of modulus I'm using, so please just check. And this is mod b, mod c, mod b minus c, like that. So what you proved? You prove this is less than equal. No, this is less than equal, right? So you prove this is less than equal to. So this is same thing as what asked to prove here. AB minus b, this one, sigma AB minus b is mod c, this one. So I got that answer. So I got that this is true, right? So I can write by simplifying that one, that pa square by this answer, that pa square, this one pa square CACB and PB square BAC, and this is equal to ABAC BC. So you will get that one. Okay, is that clear? Yes. Okay, let me go to the next one. I will come back to it later. So first let's do this one. Real numbers satisfying this one. Prove that. This is also a really difficult question because you don't know how you will start and how you are going to end up. But don't worry, not all is lost. Now, given x, y, be real numbers such that x plus y plus g is x, y, g, we know there is one such number 10, a plus n equals 10 c. So there are some numbers. You have to prove this is equals 4x, y, g. This is okay. So I will use algebra. So use sigma wisely. So sigma x 1 minus y square 1 minus g square is there. So I let sigma x 1 minus y square plus g square plus yg. Correct? This is you are just expanding. So sigma x 1 minus y square plus g square plus yg. So this is sigma x minus sigma x y square plus g square and minus xyg. Because this is xyg, so we need not worry about that, right? It is sigma xyg. Y square g square. So xyg and yg. xyg and yg. xyg I can take out. So this we can do. Just check the work that it is correct or not. Just check it first. Yes, if you have checked, then I can proceed further, right? Okay, x, y, g, because x square, y square, g square. Now, if you do sigma, your answer will be, your sum will be, or left hand side will be, left hand side is xy, sigma x minus sigma x y square plus g square minus xyg sigma yg, like that you can write. So basically this we have to minus x, this we write little this one, minus sigma x y square plus g square. This only have to work correctly. If I collect with this one, it will be all right. So there is one relation here that I am writing on the next page, that x times y square plus g square, y times g square plus x square plus g times x square plus y square. That one form is this, that x square y square plus xy x plus y plus yg y plus g plus gx g plus x, like that. This is same thing. Anything not clear or all clear? Just check and tell me. Yes, all of you. Okay. Okay. Now, if it is this one xy and this thing, so let me write it once more, because I think it is little. So this is xy, x plus y, yg, y plus g, plus gx, g plus x, this one. So I know some other thing. I know this one. For example, I know that x plus y, y plus g, g plus x. I know that this equals x plus y plus g, xy, yg, gx minus xyg. This we know. X plus y plus g plus x. Because 8 terms will be there, 8 terms, and then this is 3 and this is 3. So how do we plan this one? How do we plan this one? So reason is this, that if I write here, if I write sigma x square y plus z, or xy x plus y, if I write sigma xy x plus y, then this number is xy plus yg plus gx, x plus y plus g minus 3xyg. Correct? Because 8 terms, 9 terms are there, and 3 terms are out to 3xyg. So I get this one, xy plus yg plus gx times x plus 4. It is sigma x, sigma xy minus 3s. So 3 sigma 3 something, 3 sigma 3, like that. xyg is enough, 3xyg. We have to piece together some result, this result. So already we got sigma x1 here. So I write sigma x minus sigma x y square plus z square, and minus xyg sigma xy. Sigma x I will leave right now. Sigma x y square was g square. So sigma x y square plus g square is this much. That is this one. That is this one. So that is minus of. That is minus of. And this I can write in this form, because this form might be useful. Or even this form is also good. So this is 3xyg. So I will write here. This is minus of sigma xy minus sigma x, sigma xy, sigma x, sigma xy. Just check that all of you understand. If not, then please let me know that what part is there. Yes, so okay, so do you understand this and you're seeing this? Okay, so sigma x. So sigma x. So this I am right. This I will write as sigma x minus. This expression becomes sigma x times sigma xy minus 3xyg and minus xyg times sigma xy. Now I use the fact that sigma x is xyg. I think if I use this fact, then it will be clear. Let me check here that we got all the things correct. Here it is plus ay square, so it will be plus. In fact, it is plus here. See, this is plus y square g square, so plus. So that will cancel. So you have got here all the way plus only. You have got here plus. This is plus. So you see this will cancel. xy, xyg and sigma x, because sigma x is xyg. That is cancelled. You are getting sigma x plus 3xyg, and sigma x is because xyg, and so this is 4xyg. So this is based on the identities that you can know, and you are doing this thing. Okay, is that all right? Okay, let me go to the next one. again you have to factor this equation. Factor x square minus yg, y square minus gx, and other thing g square minus xy. So nothing helps here much. So I mean that you may go by brute force. So let's call it p. Let's call this as p. So my p becomes x square minus yg, y square minus gx, and let me write sigma so that I can understand this. So this will be x square y square minus x cubed g minus y cubed g minus xy g square, right? So this I'm getting. So let me write now. This is x square y square minus x cubed g times x cubed plus y cubed minus xy g square. Similarly, other things xy, yg, and gx. So for example, this is all sigma. This is all sigma. So what I'm getting? I'm getting x square y square g square plus g square x square. This is one. Then here I am getting this other terms, right? Means I am getting minus sigma z times x cube plus y cube, and here minus xyg square. So I will get here minus xyg x plus y plus g. This we get using this one. So this, let me keep this one here only, and let me see that what we can write here. Here what we can write, this is sigma g x plus y cube. This is again interesting, sigma g x cube plus y cube. I will touch up a bit. Sigma g x cube plus y cube. How we can play with it? Any idea? How we can play with this one, that sigma g cube and g plus this. So let me add the thing. So x cube plus y cube times g, x cube plus y cube times g, gx cube plus y cube, sigma. I can write this as x y cube plus g cube, y g cube plus x cube plus gx cube plus y cube. It can be written in this form, or other form is I can combine xy cubed plus yx cubed. So I can write, notice this one, xy x square plus y square, this one. So I can write this one as xy x square plus y square plus g square minus g square. So this is xy x square y square g square minus xyg times g. If you do sigma of x y cube plus g cube, then that is equal to xy plus yg plus gx times x square y square g square, this one, and minus xyg x plus y plus g. Just check this, that we get this one, xy plus yg plus gx minus this. So we are getting this result. This result we are getting good result. This result we are getting this one. So our expression becomes now, see, this is x square y square g square plus y square g square x square. So if I do this, I will get p is x square y square g square x square, and this is negative of x, so negative of sigma xy sigma x square and plus xyg times sigma x. This we are doing. This is, and then last here, here you have got minus xyg x plus y plus g. So I'll write minus xyg x plus y plus g. So this way I can write as, this is xy plus yg plus gx. So we have xy and 2xyg. This is actually, this will be 2xyg, because this is, you have got, just check, it is 2xyg, because plus xyg, they are negative, and this is actually positive. This is actually positive. This is positive, and so if you have got this as plus and this as plus, so ultimately plus, so you get x square y square g square x square plus 2xyg x plus y plus g minus xy yg gx and times x square y square g square, this one. So this is actually xy plus yg plus gx whole square and minus xy yg gx times x square y square g square. So I can take that common. So if I take that common, if I take xy plus yg plus gx common, I will be left with xy plus yg plus gx minus x square minus y square minus g square. Is that clear? I hope there is no glitch, although always susceptible that some glitch is there. So I get xy plus yg plus gx minus x square minus y square minus g square, and here you've got xy plus yg plus gx, this one. Okay, so if it is clear, then I can move forward. This is a tough problem, very tough indeed, because see, you have got this kind of thing, that you have got x minus yg. So brute force works, but then clever manipulation, clever. So ultimately you get some clever. So clever manipulation you get, and so I will say it is a difficult problem. It was asked in some contest in which you have to factorize that, or somebody can ask you the value also of this one, that they may give x, y, g and other thing, and they can tell you the value. It does not depend on other thing. It is just that I need to give x plus y plus g or other things, then you can find the value. Even these two are related, because x plus y plus g whole square, I can check. Okay, let me do this one. AB is cyclic quadrilateral with circumradius r. Prove that ABCD is this one. This is one problem where lot of solutions are available, but the complex number one will be easy to do. So the complex number is like this, that first of all you try to find out that how ABCD will come. So for that I'll make a diagram. I will make a diagram like this, and you have got this kind of ABCD. You have got this kind of ABCD, right? So if ABCD is there, and let's suppose that O is the center here. O is the center. So let me draw like this. So you have got this kind of thing, that, and O is the center. O is the center. Okay. So O is the center. So what we can write here, ABCD. Do you think that we can write some kind of identity? Some identity will be useful, especially if you see that how ABCD all will come. ABCD all will come. So first this O you take to be origin. This is origin. Origin. This you take to be A, B, C and D. ABCD. So this is ABCD, right? So this is A, B, C and D. A, B, C and D. Now in this ABCD there is one advantage, that this length is now OA is R, 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 all are R. So that is also nice, that OA mod A is R, mod B is R, because it is 4 variables. So I think of some 4 variable thing. So the thing that comes to my mind, see, for 3 variables you think of A square by A minus B, A minus C, B square by B minus A, B minus C, and C square by C minus A, C minus B, equal to 1. That we know from this one. No, now let me write it for cubic, because cubic and then 4 variables, not 1, not 3, 4 variables. So I can write that you have got a cubed upon, this is actually, this is sometimes called Euler's identity. Euler given so many things. A cube by a minus b minus c minus d, b cube by b minus a times b minus c times b minus d, plus c cubed by c minus a, c minus b, c minus d, and plus d cubed by d minus a, d cubed by d minus a, d minus b, d minus c equal to 1. So this will become 1. Is that clear? That why this is 1? Yes. So this is 1. Now I will apply this on this one, AQ, BQ, CQ, DQ. So when you multiply it, you will find that you will get AB, AC, AD. So AB, AC, AD will get whatever is not available, right? Fourth one you'll get. So if you multiply a cubed, so we'll get a cubed and AB, AC, AD. So there are 3 things. So you will have 3 more things coming up. 3 more things coming up. Or just take mod of this. Maybe you can take mod, then you'll be fine. Or you take just one. So this is AQ, just one first term, AQ, AB, AC, AD. So I will have here in the denominator you will have AB, AC, AD, BC, BD, CD. So you got AB, AC, AD in order, BC, BD, CD. This you get. So here we'll get A cubed and A minus B, A minus C minus D is there. So we'll get B minus C, B minus D, and you'll get C minus D. Similarly, other thing will get plus B cubed, B cubed. So B minus C, B minus A, B minus C, B minus D is there. So B minus C is there, B minus D is there, B minus A also is there. So I will get A minus C, A minus D, and C minus D, or minus D minus C. So just those signs will not matter because I'll take mod ultimately. This is 1. Now take the mod, bring to this side and take mod. I'll write the first term only. So you will get modulus of A cubed and then B minus C, B minus D, modulus of A cubed, modulus of A cubed. So you are taking modulus of A cubed, B minus C, B minus D, and C minus D, and C minus D, and similarly terms like this, 4 terms like this, and this equals modulus of all numbers, A minus B, A minus C, A minus D, C minus D. You will get like this. These things we get. So if you get like this one, then what happens? That A cube minus C minus D, C minus D. This we are writing as modulus of A cube. So this is we apply the modulus inequality. This one, modulus of P plus Q plus R plus S. This modulus, this is less than equal to modulus of P plus modulus of Q plus modulus of R plus modulus of S. So we are getting, this is actually, if this is P, this whole thing, we are getting P greater than, P less than equal to modulus of A cubed, B minus C, B minus D, C minus D, and so numbers. So this whole thing is less than equal to, or I will say that this is greater than equal to this. This is greater than equal to P, right? So how do you write that? Now A cube, B minus C, let's interpret that term. So that A cube is R cubed, B minus C, B minus D. So this is BC, this is BC, BD, and CD, and plus so on and so forth. Now we know that area of BCD, this one BCD is BC, BD, CD upon 4R. This we know, upon 4R. So BD is 4R BCD. So I'll get here, so this becomes 4R cubed. So first one becomes 4R cubed times ABC. So 4R cubed times ABC. So what that becomes? Now 4R cubed times BCD. Here 4R cubed times ultimately BCD. So in the next step you will have, 4R cubed so 4R cubed or 4R4 will come now, because of course you have got this one now. So R4, so 4R4. So you have got 4R4 ABCD. So BC. Sorry for the technical glitch. Can you hear me again? I hope now you can see me. Yeah. So I was doing this problem. So we were doing, in fact, this one, in which so I was doing this one, 4R cubed B plus C plus D, and you get ABC plus ABD and plus ACD. This 4 you get, and this is greater than equal to AB BC CD AD BD CD. And so this of course is twice of, you understand, you will find this as twice of ABCD, so you will get 8, this is 4, 8R to the power 4 ABCD, and this is greater than equal to this one, these 6 numbers here, that is AB. If I write in order, AB AC AD BC BD CD. So we have already proved what we wanted to prove. That you can check that this was the thing to be proven, so we have proved this one. Dimensionally also it is correct, because 6 numbers are coming up. So I hope that thing is clear. Let me just tell you, because there was a glitch. So let me just say that what exactly we did. So what I did was this, that you have got ABCD as cyclic quadrilateral ABCD. So this is got, so it's not 90. So let me just make it a little tilted so that we understand it is not 90. So we have got this ABCD as cyclic quadrilateral ABCD. And so what I did, that I told you that this is ACD, this ACD, and plus ABC is ABCD, one is this diagonal AC, and also diagonal BD also I can write. So BDC plus BDA, this also is ABCD. You can triangulate in these two manners. Other manner could be like this. This is the thing, and this is B and D. So this is BDA and BDC ABCD. So that we are doing. So I got from here, I got 2 ABCD. So after the complex number thing, I got here 4R to the 4 BCD. This other thing we get, and from there we can still command our thing that we'll get this one. So that is the one thing we'll get to know. So I hope that is clear. And this and one thing more was that we used that if there is a triangle PQR, if there is triangle PQR, then we will use that PQR. If there is a triangle PQR, we will use PQR is PQ times QR times PR, so ABC, and upon R, 4R. So delta is ABC by 4R that we are using. So this is also one example for trigonometry which is often useful. So we can get these things done. There are a lot of glitches today. So I don't know, there is something at the technical end, or maybe that I'm at my laptop end. I still have to figure that out. So it will be a little slow. The streaming is, I think, not as per my test, but still, please bear with it. My apologies for the same. Okay, so based on this, we have done these things now, and one overview of the problem that I wanted to do is this one, or some hint I can give you. So this we have already done for xyg. This is the thing I have to do. I will get you started on this one. So first step is AB a square minus b square plus BC b square minus c square plus CA c square minus a square. That is now the way I told you that if you, it is same thing. If you combine this ABA square and this is with something C part, so this is BC and CA, so you combine this with AC C square minus A square, so you combine with this one, so you will get A cubed B minus C, sigma A cubed B minus C, and that we know. Sigma A cubed minus B C, we know this negative of A minus B, B minus C, C minus A, and times A plus B plus C. So this becomes modulus. This is an IMO problem, right? So its first major step is this, that you're writing A minus B, B minus C, C minus A times A plus B plus C less than equal to M times A square. This you want. Obviously degree 4 is here, so we want this kind of thing. To clear mod, you do the ordering. So you write A less than equal to B less than equal to C. Ordering might be helpful. If you do the ordering A less than equal to B less than equal to C, then I can write this as B minus A. This is B minus A. This is C minus, so B, this is B minus A. So we have this as B minus A, this as C minus B, and this as C minus A, and then A plus B plus C. And this less than equal to M times A square, B square, C square whole square. This we have to take care of it. So for that, it is a beautiful problem. For that, what you have to do now is that B minus A. So B minus A. So what I will do, that this I will already have said that A less than B less than C, right? Ordering has been imposed here just to take care of modulus. Now if that had been done, then next we will go so I'm writing B minus A. Remember, ordering was A less than B less than, so B minus A, everything positive I will take, B minus A, and then C minus B, and then C minus A finally, and this is A plus B plus C less than equal to M times A square plus B square plus C square whole square. This we are writing. So first we apply AMGM and we say B minus A, C minus B less than equal to, we will work with extremes, less than equal to B minus A plus C minus B by 2 whole squared. So I am getting B minus A, C minus B less than equal to C minus A squared over 4. This is 1. So it means I can combine, I can write b minus a times c minus b times c minus a less than equal to c minus a cubed over 4. This is one thing. That's all right. This is one thing we get. Now a plus b plus c is there. So how to combine this one? B minus a, c minus b. So for that to happen, you need to have this kind of thing, a plus b plus c and c minus a cube by 4. So a plus b plus c is actually, you can write like that, this is a plus b plus c whole square. So I can write this is c minus a cube by 4. So I'll just write c minus a cube by 4, and then, so is that clear, that c minus a cube by 4, why it is coming? C minus a cubed by 4. This is here. So I will write here that b minus a, c minus b, c minus a plus b plus c, a plus b plus